These are singles, they're IGBTs, they're rated at 400 amp, 600 amp max. So 51, 52, 53. They're 8 times more powerful than this one. And they're much easier to make a tidy controller out of because you can just bolt copper bus bar straight to them. So with these ones, what you'd end up doing with singles, you'd need 6 to make up a 3-phase inverter. So let's say you had 6 there. You could line them up like that. If you look at the drawing, you've got your collector on pin 1 and your emitter on pin 2 and your base there. So what you could do is have a big positive bus bar there, just bolted to all 3 of these. Then you'd have to have a bus bar running to connect these together. And that would also be your 3-phase output. You could either do it in the middle or you could just bolt it to one of these. And you'd have your negative rail across these 3. So that'd be quite tidy, wouldn't it? And the heatsink is actually the bottom plate, so you put a bit of paste on here. You've got to watch out that they're insulated. So these are internally insulated, so you can put these metal parts together on a metal plate and it won't matter. These little black ones I've been using aren't insulated. So you've actually got this ceramic, you see that white stuff? So that'll stop. If I can get it to focus. Focus. Yeah, you got this little ceramic thing. Let me show you a piece of that. And that basically stops the metalwork touching the heatsink because they'll short each other out. It's either connected to the collector or the emitter, I can't remember. But here's a piece of it. There. So you put heatsink on both sides and it stops it electrically isolates it from, so this allows heat to pass through it but not electricity, so it electrically isolates it from the heatsink. So if you check your data sheets on these are the semicron. These are electrically isolated internally, so you can bolt these, basically means you can bolt all these to metal and they won't short out. And then you've got these half bridges, which is pretty much 2-in-1. So what they've done is built those 2 into one module. Now, these are only 200 amps though, so they're not very powerful, these ones. But that would be even easier still. You'd have your positive and negative bus bars and your 3 phases out. Quite simple, and all the rest is done internally. Here's your gates. Much easier to use these. The only thing is they're very expensive. Right, let me just show you a really handy, really quick test you can do with your IGBTs, just to see if they're working or not. 12-volt battery, light bulb gets hooked up to positive. Trying to do this through the camera is difficult, and you see there we've got a nice light bulb. Okay, cool. Instead, what we do for our test circuit, we'll hook up the collector to positive, load somehow. There we go. Then we're just going to hook up the collector to negative. And this is going to demonstrate 2 things in one here, so I'm killing 2 birds with 1 stone. So there's your quick, simple test. With my 2 fingers, one on the base, I'll use my body to charge the gate and my body to discharge the gate. Charge, discharge, charge, discharge. So I think you'll agree that we've got a good IGBT there, and they're all pretty good. I tested them all. Now, that's one. You've learned an easy peasy test. Second one I want to show you The IR2110 circuit, the gate resistor size. Now, if I lick my fingers, get them nice and wet, lower the resistance. Watch this light bulb. Right? Fast as you like, innit? Now, I'm going to put an incredibly high amount of resistance. So I've got a bit of dry skin on the end of my finger there. Just going to gently touch that base, and I'm going to gently touch the positive. So this is going to be a really high gate resistance. Can you see that? And I'm going to discharge it the same way through my fingernail. I don't think it works through my fingernail. A bit of skin. There we go. So you see how slow that is? Just touching that. There you go. It's in the active region. You don't want that. You do not want it in the active region. Whilst it's in the active region, this will be acting just like a resistor. So you talk about the amount of current and voltage that we're looking at here through the... Now once it's out of its active region, once that bulb's fully on or fully off, it's not in the active region. But whilst it's in the active region, i.e. half on, half off, this will act just like a resistor, so it will get boiling hot and you'll kill it in no time. So the idea is to have a low enough, kick the camera, a low enough resistance to have it on in a decent amount of time, but not too much resistance so it's going to take too long to switch on and off, so it's in the active region for a long time, because you don't want that. And equally, you don't want too low a resistance that you're going to blow up the IR2110 chips. Hope that helps. I thought you'd like to see the same test with the little ones that I've been using. So just for comparison, there is the equivalent of 8 of these in one of those white ones. So, collector. The collector goes, I'll try and cover that up a bit anyway. So the collector goes to the positive, to the positive, through the load, and the emitter to the negative. There we go, same thing. Let's compare the gate with my high resistance charging. See, there's not a lot of difference there, is there? Very similar characteristics. So yeah, I think the IR2110 will charge it up just fine. Yeah, I'm touching that. Very similar characteristics, if not identical. I'm quite pleased with that. But yeah, very similar gate characteristics from the small ones to the big ones. So there'd be no special requirements to drive those. The old circuit should do it fine.